Hello and welcome back. Yeah, a lot has happened in the last 2 weeks. I did some improvements to my wave function collapse. I did some improvements to the overall visuals of the tile map, and I ported back my old tanks and weapon system. Made some basic animations so they don't look as dull. You already saw in the intro my tank start animation. It's currently just a placeholder to have some fun. And yeah, I added shadow as well. So the sound, by the way, was just an overlay, it's not implemented yet. So today I guess I'm gonna show you some of Godot's cool new features, as well how I use them in my game, and hopefully they might help you as well. Especially the shadows and state machines, I'm gonna talk about that, and yeah, enjoy. A really nice feature of Godot 4 are canvas groups. Canvas groups allow you to modify the texture of multiple texture underneath that node. It's basically the same thing as viewports in Godot 3, but more simplified, more easier to use, and they are quite perfect, for example, to use as a top-down shadow shader. I wrote one pretty quickly. It's quite easy. We basically just for each pixel we look at a neighboring pixel by a certain offset, and if that one is in fact a colored pixel, we check that by checking the alpha value. Then we color the current pixel in the shadow color, as long as it's a transparent pixel before, so we don't overdraw the actual picture. And that results in a really nice shadow layer around our object, which we then can modify. We can zoom. Okay, I cannot zoom that here right now, but you can modify that by modifying the offset via a script, so we can simulate the sun, for example, in game. It looks like this. It's also animated. That is really nice. It was really hard to do in Godot 4 and Godot 3, but in Godot 4 it's very easy. And for anyone who does top down, this is quite nice. It makes everything looks just so much better with shadows. Quick look at Godot's 4 new lambda features and why it's so nice to have those. Before, when we wanted to make a state machine, we needed to make a bunch of nodes and interact with these nodes and have a big scene tree, and I really didn't like that. This was something why I always preferred C#, where we could just abstract that away from the engine itself. But now with lambda expression we can do that also in GDScript, and I quite like that. I defined 2 classes in my core, the state machine and the state. Here's a quick look if you want to copy any of that. It's basically the state holds a bunch of callables, the onEnter, onExit and the tick function, and the state machine handles the transitions between those states, defined by a subclass called transition, which just defines a from, a to state, and a condition that has to be met for this transition to occur. This looks like this. In our weapon we have our 3 states we need: the fire state, the reload state and the idle state, and we define a bunch of conditions for each state when they should transition. For example, the fire state should go to the idle state as soon as fire is off, and vice versa, the idle state should go to fire state as soon as fire is on. Then we have an any transition, so it doesn't matter which state you are currently in, go to reload state as soon as clip reaches 0, and then go out of reload state as soon as clip is reloaded. That's quite simple, quite powerful. We can now map a bunch of, for example, I can make state on exit, and now I could define a function where I don't know, play, leave, reload, animation. This is quite powerful. I mainly use state machines for animation right now, and with this kind of control I can add animations to any kind of state change. For my whole weapon to function I just need 2 states defined: the on fire state tick and the reload state on enter. The tick fire state function just does what it should do. It takes a timer and it looks, am I ready to fire, should I fire, what does my weapon RPM say, and then fires. And the reload state just creates a timer and awaits until the timer is gone. the timer is defined by the reload time, and at the end it resets the clip size back to its max capacity, which then triggers the next transition out of the reload state. Quite a nice system. I'm glad we have that in Godot 4 now. Okay, let's take a look at my wave function collapse plugin. I have a demo scene here with a couple of tile maps where I draw a pattern, and then I take my plugin, display the grid, and for each cell, as soon as I press the slice button, I generate a new tile map pattern in a custom resource. And it stores its connectivity rules via a hash for each side. These are just hash values generated by the sequence of tiles on a certain side, so they always result in the same hash. As you can see, this one has the same hash to the left as to the right side, because they could technically connect. And then I have some special utility options here where I can give a weight to the tiles so they occur less often or more often, and I can also name them or group them so I can interact with them via some code injections into the algorithm at a later point. This is my current test setup. I have instead of making small tiles, I make huge tiles now that look like this, and I have saved that as a resource. We can modify that. For example, we can say that this tile has a weight of 1000. We save that, go to our main scene, look at our wave function collapse special tile map, and there we have that resource assigned. And when we start the game now, we should notice that we have a lot of straight tiles here, a lot more than the other tiles, and the world is infinitely generated around the player. Yeah, and we can pretty much modify that pretty quickly. Let's, for example, say that this one is 1, and oops, this one is 1 as well, and then we want to have a lot of 4-way connections, and then we save that. And if we start that now, we should get a completely different okay, this may be a little bit too much, but yeah, this is the current idea. Yeah, that's it for today. Leave a like or subscribe. Until next time, bye!